In the last section, we put together the first iteration of our status checking program. But if we look carefully at the output of our program when we run it at the terminal, we'll notice some pretty interesting behavior. So I'm going to run the program, and when I do, you're going to notice that I get a little bit of a delay, then the print for Google, and then a delay, and then Facebook, delay, static overflow, delay, and so on. And so it appears that there's a little bit of a distinct delay between fetching each of these addresses right here. So let's take a look at a diagram and try to kind of picture exactly how our code is being executed right now. Okay, now this is a kind of a crazy diagram, but we'll go through it step by step. So on the left-hand side over here, we have a list of all of our different addresses, or all the different URLs. So here's what's really happening behind the scenes when our program runs. We take the first link from our slice, we make a request to it. So this is a request that goes off to google.com, and then we sit around and wait for a response to come back. And so the line of code inside of our check link function right here, this line right here, whenever we make a request to a link, we are sitting around and waiting for that request to complete. So we make the request, we kind of sit and twiddle our thumbs, and we wait for a response to come back. And so we do not progress on through the rest of our function until we get a response back from this function right here. So what that means is, every single time we're making a request, we sit around and wait for the response to come back. We then take the next link, make our request, sit around and wait for our response to come back, and then repeat over and over and over again. And so essentially our program is running in a very sequential or kind of serial flow right now. In between each fetch, we are just sitting around and waiting for some amount of time. Now I want you to kind of think about the program that we're writing right now and its purpose and why that might be a little bit of an issue. If we ended up having many different links inside of this slice right here, like let's say thousands of different links, that means that we can only ever check any given link like once per hour or something like that, because we're only making one request at a time. And to check another link again, we have to run through the entire list again to come back to the very top. So I'm going to suggest that maybe this is not the best approach for putting our program together right now, especially considering that we might want to check google.com or golang.org several times in a row very quickly, rather than waiting for us to finish Amazon and then loop back over to Google and then go through Facebook and then Stack Overflow and then finally get back to golang.org again. So I'm going to suggest a slightly different approach here. I'm going to suggest that maybe we want to take a kind of parallel approach to this program. Maybe rather than running each request in serial, maybe we should take each URL inside of our slice, make a request to each one, and then whenever any request response comes back, we'll then print out the status. And so the key in this flow right here is that we're going to attempt to make every request right away, like as soon as our program starts up, rather than waiting for the previous request to finish and get a response back and print out its status. And so this is where the idea of Go routines and channels is going to start to come into play. So let's take a quick pause, come back in the next section, and we're going to talk about how we're going to make use of Go routines to run each of these requests in parallel. So quick break, and I'll see you in a minute.